Hey guys, welcome to another episode of Scientific Minds Unite. I'm Mr. Myers. You don't normally see me, but I am a teacher here. I'm a 7th grade science teacher here, and we're going to be showing you another example of science live today.
Mr. Myers.
Yeah.
You're behind the camera, aren't you?
Yeah, I'm sorry.
Yeah.
Okay.
Let's go.
There's nothing like a nice fire to warm up by on a cool fall day. As I'm standing here enjoying this fire, I'm thinking about what is a scientific process that we could talk about that is so important to the world around us, and it drives life. We need it. It's right on the tip of my tongue, and I just can't put my hand on it and put my finger on it.
Hey, Mr. Nissen.
Oh,
Mr.
hey,
Nissen.
Mr. Van Newkirk.
Hey,
how are you?
one scientist to another, man. Hey, funny you should ask about that single most important factor that just really helps us survive and live. And I think the answer is water.
Oh, yeah, I think you might be right. You're onto something. So
nice.
the water cycle.
I agree. I think
Okay.
the water cycle.
Okay. So, we have this fire,
Mhm.
and we have this pan, and it's being held up by rebar. I don't know how we could possibly use this to show the water cycle.
Interesting. We're going to need some water. But, water comes in all different forms. It comes in a solid form. It comes in a liquid form. It comes in a gas form. It's kind of fall and the temperatures isn't really cold. I think I saw Mr. Hammond over there at the grocery store. I wonder what he's getting.
Oh, yeah.
I'm glad you asked,
Hey,
Mr. Van Newkirk,
There's Mr. Hammond.
because I brought us, you were talking about the different states of matter here, and I brought us some ice, good old-fashioned H2O in a solid form, although it is beginning to melt. But quite honestly, I don't even know why I have it. You guys told me to bring a bag of ice. I thought we were going to have a cookout, and I'm a little disappointed I don't see any hamburgers here.
Yeah, that's a good point. And, we're talking about the water cycle.
Oh,
And we thought that if you brought some water, maybe that would help us, kind of recreate
okay.
the water cycle. We have heat. We need heat, right, to start kind of the process, the water cycle process.
Where do we normally get heat in the water cycle?
Well, normally we get it from the sun.
Okay.
Yeah, but today the sun's sitting on the ground.
Okay,
Right.
gotcha.
So-
Okay.
We have to kind of pretend, right?
All right.
And then we need water, but then we also need something to kind of represent the atmosphere, making it cool off. So as that water vapor rises, it's able to cool off. So
I think that's where I come in.
enter you.
Okay,
Yes.
gotcha. So
Yeah.
I'm gonna provide the cooling, because as you know, as we travel up into the atmosphere, it gets colder and colder
That's
and
right.
colder. And so I'm gonna see if I can get this pan to be a little bit colder here. So I'm gonna put this ice on top, and I'm gonna let it sit there. Hopefully our rebar is gonna hold us here. And I'm gonna let it sit there for a little bit and see if I can get this pan to be colder and represent, again, that higher altitude. And I think we should maybe just wait just a minute
Yeah.
and see if that happens.
Just give it a minute and see what we see.
I got a major discovery already. I wonder if they call it ready ice for a reason. What do you think? I think it's ready.
It's ready to go.
It's ready to go.
Yeah, we already see it's melting up here, cooling off a little bit. It's cooling the pan. That heat is transferring through the pan into the ice. So we know heat transfers from hot to cold.
Absolutely. Okay. Well, I think we're going to have to wait for a little bit to see if we're going to get any kind of reaction as far as showing the water cycle. So let's take a few minutes and let it do its work, and we'll come back and take a look at it.
All right.
All right.
Oh, the fire's still going though.
So if you're just joining us,
That didn't work.
wow.
Yeah, that was a hot mess.
That was a
pun
failure.
intended.
Yes, exactly.
Yeah, so our legs fell out of our tripod.
Right.
The ice went into the fire. Of
Yes,
course, it
that's
didn't
exactly what
fall
happened.
out. And yeah,
And I blame really Mr. Van Newkirk for the whole thing.
it really was his fault.
Yes. All right. So we're going to move on.
We need to try something.
We decided to try something different. That's what we got to do. We, you know, things go wrong. We don't give up. We keep on working. So we're going to put this on top of the fire, and then we're going to add a little bit of water to hopefully replicate, you know, the accumulated water on the ground. The fire, again, of course, representing the sun or the heat source, and that should apply it to the water, and then we're going to see if that water can start to maybe boil, molecules getting real happy, and then we're going to apply a layer of ice in another pan above that, and we're going to see what happens. Let's just give it a shot here. I'm going to put this on top here. Mr. Nissen, you want to come over here and get some water?
So it looks like that pan is nice and even, so we won't have any
Yeah,
problem with it running off the end.
Perfect.
Perfect.
Yeah, just as I drew it up. Very good.
Yeah. Nice.
Okay.
All right, so now we need to get the ice, right? We need
Correct.
to. Okay. So
Well, I've got the rods of science, and I'm going to attempt to hold these rods with all that ice with my bare hands. Well, not my bare hands. I brought Minnie. Hold up. I brought Minnie along. Say hey to Minnie. All right. Let's see what we got, fellas.
you ready for us?
Yep.
We've got a lot of smoke, so what we got here.
Woo.
Okay.
Water cycle is smoking.
Now remember, the ice represents the cooler temperatures in the upper atmosphere, because when we have evaporation, of course, as it rises, it becomes less dense and it rises, and of course it gets colder, it becomes more dense, molecules come together and create tiny droplets of water. And so we're hoping that we're going to see something like that in the next few minutes. And I know you all are on the edge of your seat right now. So.
Oh, we already have a little bit of evaporation happening right there.
Absolutely.
See that?
And so, as the heat rises, the water is you know, a little bit at a time. It doesn't all happen at once. Molecules are starting to get super happy. Some at the surface will eventually change into a gas, to a vapor.
You know, Mr. Hammond, there's something pretty interesting about boiling water.
What's that?
And I don't know if you know this or not. You probably do because you're a science teacher.
Yes, sir.
But water can only boil once the heat or the temperature of that water and the pressure pushing up on the air is equal to the atmospheric pressure or the air pushing down on that water.
Wow.
Only then, when it's completely equal, will it actually start to boil.
Wow.
Pretty interesting thing here.
That is interesting. Good. Do you know what the temperature of boiling water is, by the way?
Well, it depends on if you're talking Celsius or Fahrenheit.
Well, we are scientists, so we wouldn't be talking about Fahrenheit.
No,
We're talking about Celsius.
Celsius would be 100 degrees.
100 degrees.
Yeah.
Excellent. Fantastic. Man, I'm excited. Mr. Myers, I think you're going to get down here a little closer.
Okay.
Because science is happening right under this pan right here. Let's take a look. You can see, we're starting to see condensation develop on the underside of that pan. Ladies and gentlemen, that's a beautiful thing. The water vapor has hitting the colder pan and immediately turning back into tiny droplets of water. Oh, that's a good time right there. So, Mr. Myers, are you seeing it?
I'm seeing it.
Are you seeing it? We're actually seeing an example of precipitation. The water that condensed on the bottom of this cool pan, again, representing the upper atmosphere. The water droplets are getting larger and heavier, and when they do that, gravity takes over, and oh my gosh, we have precipitation. Do we have the whole thing? Do we have the sun? Yes. Do we have the water? Yes. Do we have a representation of the clouds? Yes. Do we have precipitation? Double yes. So Van, or Mr. Van Newkirk, what have we learned today?
Well, you know, I've learned many scientific principles today about why you shouldn't touch hot pans, you know, about how you need heat. to stir the water cycle. But our focus was the water cycle. So let's just recap real quick, guys, okay? First of all, we needed a source of heat. In the water cycle, the sun is that source of heat. It's that engine that drives the water cycle. It heats the water, in this case, the water in the pan. Those water molecules start to get happy, they start to move about, and then the water turns into a gas, goes from a liquid to a gas, and begins to rise up into the sky. As it rises, it cools and condenses. And that was the other pan full of ice. That represented a cool atmosphere. And then the water changed from a gas back to a liquid, kind of like a magician just making something appear out of nothing. So, water molecules began to appear, they started to accumulate, started to get closer and closer together, and eventually became heavy enough where gravity pulled them back to the earth as precipitation.
Speaking of,
Yes.
we did a pretty good job.
Yes.
I agree.
Fantastic experiment.
It's starting to rain right now.
It is.
That was all created by us, guys. We did that.
Only
Thank you so much, guys. We appreciate you joining us for another rousing edition of Scientific Minds Unite. Come back to us next week when we have something. Who knows what we're going to have next week. Hopefully we won't burn ourselves next week, but we appreciate you. Take care and have a great day.